so far we have only been dealing with functions that's defined from negative pi to pi, but for usage in PDEs, you actually need the Fourier series for arbitrary lengths. Okay, so now the question is, can you modify this so that the Fourier series approximates a function over negative L to L? Right? So what do you do if you want the Fourier series from negative L to L? Well, you could live with this formula by doing the following. If the function is defined from negative L to L, then you can multiply by L. What does that achieve? If you replace x by L times x, let's say L is 2. If you have f of x and f of 2x, what happens to the graph?
It's compressed.
Compressed by 2, right? So this will be on negative 1 to 1. And now you divide by pi. Right? Then this will be on negative pi to pi. By the way, don't write this. It's not. This part is just to think about what's happening. Okay. I'm going to organize the formulas again nicely, and then you can write it. Okay. So now you can take the Fourier series of this thing as something like that, right? Yeah. But then, how do you go back to x? Well, you replace x by pi x over L, right? So this will be equal to this for some value a0, an, bn, with this being in there. And if you replace x by pi x over L, then L over pi and pi over L will cancel, and you're just going to get back your pi f of x. So that's what's going to happen. And the result would be that the Fourier series will now look like the following, because you're replacing x by pi x over L, and there's an n there, so that n's still there. And then bn sine n pi x over L. So that will be the formula for f of x, right? But then we also need to change these values as well, because remember when we did the change of variables of f of Lx over pi, so when we plug this in here, this will be modified as Lx over pi, and then you have to replace that by u and then do change of variables. Now since it's getting really confusing, let me just skip that process. But if you took time to work this out, you'll see that the only thing that changes if you do this change of variables is that all these pi's will be replaced by L. Okay. Okay. So that's the formula for the Fourier series on negative L to L. This you can write. Okay, so the formulas for getting a0, an, bn will be these, and once you get it, then you can write down your series this way. So let me show you an example. Find the Fourier series of f of x, and let's say it's 0 when x is between -2 to 0. Okay. And then let's say this is x if x is between 0 to 2. So this is a function that's defined from -2 to 2. Notice that I don't have 0 defined, but it's okay. I mean, the integration can be defined even if you have a few points missing, right? Yeah. So if you don't like that, you can just put it like that, okay? Yeah. All right, so what's the picture for that? It's the graph is like, it's 0 and then like that, okay? From -2 to 2. And we're trying to find the Fourier series of this guy. Okay, so let's try to do the integral. A0. Okay, first, what's the value of L? For this question, what's the value of L? Two, right? It's from -2 to +2. So this is from -2 to +2 because the function is defined from -2 to +2. Right? So A0 would be 1 over 2 times L, but L is 2. Integrated from -2 to 2 of this function dx. But this function is 0 from -2 to 0. So when you integrate 0 through -2 to 0, it doesn't count. Right? The value is 0. So we just need to calculate the integral from 0 to 2 of f of x, but from 0 to 2, f of x is x. So we can just integrate dx here, and therefore you get 1/2 x squared. Plug in 2 and 0, and there's a 1/4 in front, so it's going to give you 1/2. Okay. Now, an would be 1 over 2 times 2. No, it's just 1 over 2. It's 1 over L, right? So 1 over 2, integral from -2 to 2, f of x times cosine. Okay, let's think about what goes in here. Cosine of what? Oh, sorry. I read this. This should also be n pi x over L, okay? So it should be n pi x over 2. Okay? Again, you want to do 1/2 integral from 0 to 2 of x times cosine n pi x over 2 dx. Notice that x is an odd function and cosine is an even function. So if you multiply an odd function times an even function, you get an odd function, right? Does that mean that this integral is 0? No. Why not?
It's not a symmetric domain.
Because it's not a symmetric domain, because you're integrating from 0 to 2. Only when you have -2 to +2 and you have an odd function, which means one side goes down, the other side goes up, then they cancel. Okay? Here you can't use the symmetry because the integration is done over a non-symmetric domain. Okay? That's something that you have to be very careful. Okay? Okay, so that means we have to, let me just use this part. That means we have to do the tabular integration. Plus minus d integral x, 1, and then 0. You differentiate x, you get 1. Differentiate 1, you get 0. Cosine n pi x over 2. Well, this is n pi over 2 multiplied to x. So if you integrate, what's the coefficient? 2 over n pi pi. It's the reciprocal, right? The reciprocal of this number, 2 over n pi, sine n pi x over 2. Okay? And then you integrate this again, and you get negative 4 over n squared pi squared cosine n pi x over 2. And then plus minus plus. So you get the following integral. The integral is 2x. Well, don't forget the 1/2 in front. It's very easy to forget the coefficient. Okay, 1/2 in front is here. 2x over n pi times sine n pi over 2, n pi over 2x, okay, and then plus 4 over n squared pi squared cosine n pi over 2x. Then you plug in 2 and 0. Okay. Once again, when you plug in 2, you get sine n pi, which is? Sine n pi is? 0. When you plug in 0, sine of 0 is 0 as well, so this doesn't create anything. When you plug in 2 here, you get cosine n pi, which is? Cosine n pi is?
-1.
Negative 1 to the nth power, right? And then when you plug in 0, you get cosine 0, which is? 1. And because 1/2 times 4 is just 2, that's what you get as the coefficient. So that's your AN. Okay. All right, now let's do BN. Gee, I don't have any space to write, so. Let's just remember that this value here was A0. This is now AN. And BN is integral 1 over L from negative L to positive L, f of x times sine n pi over Lx. Well, L is 2. And then that's equals to 1/2 0 to 2 x times sine of n pi over 2 x dx, which requires another tabular integration. X differentiates to 1, 1 differentiates to 0. Sine of n pi over 2 x integrates to negative cosine n pi over 2x. And then the reciprocal of n pi over 2 comes up front, just n pi. Then you integrate again, that's negative, another 2 over n pi multiplies, so it's 4 over n squared pi squared sine n pi over 2x. Plus, minus, plus. So reading from there, the result is across and goes down. So it's going to be 1/2 of negative 2x over n pi cosine n pi over 2x, then plus 4 over n squared pi squared sine n pi over 2x, and then if you plug in pi, 2 and then 0. 2 and 0. Okay. So this time the only non-zero thing is when 2 gets plugged in here. When 0 gets plugged in here, there's a 0 multiplied, so that doesn't create anything at all. And 1/2 and 2 cancel. So you end up with negative 2 over n pi, negative 1 to the nth power, as the value of Bn. Okay? All right, so now we just plug in all the values to write down the final answer. So the final answer, I usually like to write down the explicit expression for f of x, but since our f of x is piecewise function, so I'll just leave it as f of x. But when you write your solution, and f of x is given as a polynomial or something that can be written, please replace this by the explicit form, okay? A0 is 1/2. AN is this one. So I need 2 over n squared pi squared, -1 to the nth power minus 1, cosine n pi x over 2. And then for the sine one, it's that one. It's going to be -2 over n pi, -1 to the nth power sine of n pi over 2x, or n pi x over 2. Okay? So that's the answer.